Hello student, hello grade 12 learners. Today grade 10 learners. Today I'm going to be teaching you guys about mechanical energy. So we're going to discuss what is mechanical energy. We're going to discuss the conservation of mechanical energy. So let's just begin with this lesson today. So when we talk about mechanical energy, the first thing that we must talk about is potential energy. Potential energy. So, what is potential energy? Potential energy is the energy due, I can say is the energy to due to height. So when I say due to height, you can define potential energy based on the positions, so from the ground up to up top. So when I say potential energy is the energy due to height, you might be having a height. Let me just draw it with you here. You might be having a height whereby, let's draw, I'm gonna draw something like a mountain. Let's say this is a ground. My drawing is not really perfect. I'm gonna try to make it nice today. So let me just erase this line here. So let's say this is a ground. This is a ground. Okay, it's fine. Let me just use the red pen. So let's say this is a ground. So in this ground here, you can be having something. Maybe you go, and then after that, it's a trolley or something, or swing, something that it can be like you normally see this in the mall. If you go to a mall whereby you can be rolling, or a person can be in a house, let's say maybe in a mountain, then this person have to be going, running, and then up to there. So if we can take this as position 1 or position A, then you will see that from this ground here where we are, we have, it can be, let's say 5 meters. Let's use 5 meters. So there, from here to here, we have a height. So when we have a height, so this will lead us to define, it will lead us to define and make a potential energy. So in potential energy, I will use PE, use PE. So PE is equal to M mgh. So mgh, whereby when we say M, PE equals to mgh. So whereby when we say M, whereby our P, let me just say PE. So PE is going to be equals to mgh. So whereby this, our M there, M is going to be equals to mass, and G is going to be equals to gravitational force. Gravitational force, and the H is going to be equals to height. So if I have to calculate the potential energy, I will have to know the mass. Let's say this is a mass of an object that we are working with. So let's just draw our object. Let's say this is our object at A. So this object, it have 2 kg. It's 2 kg. The mass of this object is 2 kg. So in order for me to calculate this potential energy, which means I'm going to say this potential energy, which means I'm going to say to my potential energy, my PE is going to be equals to the mass, and mass of this is going to be 2. We multiply it by gravitational force. So gravitational force is always 9.8 meter per second squared. Then we multiply it by height, which is 5 meter. 5 meter. So if you use a calculation, you will see that, okay, 5 times 2, if you use a calculation, you will see that let me just get my calculator quickly. If you use your calculator, you will see that if you say we have 2 multiplied by 5 multiplied by 9.8, which is going to be equal to, it's giving us 98, not really, but it can give us 98. It's 2 multiplied by 5 multiplied by 9.8 equal to, answer is still, is fine. Answer is still 98, but I'm shocked a little bit. Let's say 2 times 5. We know it's going to be 10 times 9. Okay, it's 98, yes. So the answer is 98. So which means it's 98 because it's energy. Energy is 98 joules. It's written the units of energy is joules. So it's going to be 98 joules. Joules. So J. So normally now when we have calculated, so you will see that in this graph here, as we are moving in this graph, let's say we are moving in this graph. If this object start to move up to here, let's say here, so I'm gonna draw a line with a black. So let's assume here is 2 meter now. So you will see that this object when it's here, the height decreased. So when the height decrease, here, when the height decrease, so if we calculate a potential energy of these objects of 2 kg when it's there, so we can say our PE now, our PE is going to be, our PE is going to be equals to, the mass is still going to be the same because it's 2 multiplied by, the gravitational force is still going to be the same, it's going to be 9.8, and multiply by, now we are going to multiply it with 2 because the height now decreased 2. So if we multiply this by 2, is the same as we are saying 4. 2 times 2, we are saying 4 multiplied by 9.8 multiplied by 9.8. So 4 multiplied by 9.8, you can still use your calculator. So if you use your calculator, you'll see 4 multiplied by 9.8 multiplied by 9.8 equals to 39.2. So which means the answer for this one, we're gonna write 9.2. The answer here is gonna be equals to 39.2. So joules. So now you will see that the more you are going down, potential energy decreases. So when you get to the ground here, because the height is going to be 0, the potential energy of here is going to be 0. So what does it mean when we are moving here? Now you have seen that when you are on top the mountain or on top of someone, when it's going down and down and down, it's going to decrease, and when it goes up again and up, and when it's going to increase again. So this is potential energy. So now we're going to move to kinetic. We also have kinetic energy. Let's say kinetic energy. Kinetic energy. So what is kinetic energy? Kinetic energy, we're gonna move to kinetic energy. So kinetic energy is the energy due to the motion. A motion, we can say motion of, or how fast the object moving. How fast is the object moving? So when you say is the energy due to how, is, you can say is the energy due to how fast, due to how fast the object is moving. How fast the object is moving. So when we have this kinetic energy, the formula for kinetic energy, kinetic energy equals to 1 over 2 mass multiplied by mass multiplied by 1 over 2 mv squared multiplied by v squared, whereby v squared. So I'm gonna rewrite it properly for you guys. So the way I've written here, the kinetic energy. So kinetic energy is the same as Ke equals to 1 over 2 m V squared. So where M is mass and V, I will define only V now. So V is our velocity, equals to velocity. Velocity. It's a velocity. Okay, today my handwriting is bad, guys. I don't know if I'm not sitting in a right position. Is our velocity. So now, what will happen to our kinetic energy when A? What will happen to our kinetic energy when we are in position A? A. So let me just write it. So our kinetic energy, if we are in position A, we are the object here is 2 kilogram and it's in 5 meter. And let's assume that you are given that the velocity of this here v, the velocity is 3 meter at 3. It's 3 meter per second. Let's assume that this is our v. It's going to be our v. So now we're going to calculate the kinetic energy. So in order for us to calculate the kinetic energy, so which means our kinetic energy here is going to be our kinetic Ke here is going to be equals to 1 over 2. It's 1 over 2, which is 1 over 2 is 0.5. You're going to multiply it with a mass, which is 2. You are going to multiply again with a velocity, but your velocity, you must make sure that it's to the power 2. So it's 3 squared to the power 2. So what I just wrote here is the same as I can try to write. I want you guys to see it properly. It's the same as I've just written 1 over 2 multiply by 2 multiply by 3 multiply by 3 squared. Is multiply by 3 multiply by 3 squared. 3 squared. So you will see that this the 2 here, you can cancel it with this one. You're going to remain with 1, which your answer is going to be 3 squared is going to be 9 joules. 9 joules. So the kinetic energy at A equals to 9. So now you can be asked to calculate the mechanical energy at A. So if you have to calculate the mechanical energy at A, your mechanical energy at A is going to be equal to, let's calculate it now. Mechanical energy at A, I will say ME. The ME, mechanical energy at A, is going to be equals to PE plus KE. So mechanical energy at A is going to be PE plus its potential energy plus kinetic energy. So which means in a good writing, when you write it, so when you say mechanical energy, you can say the mechanical energy at A. Let me use the big one now. Okay, ME. Okay, this is too big, guys. Let me reduce it. I thought maybe it's going to be, I just wanted you guys to see it clearly, but it's more bigger than I expected. So I'm gonna go with the second one. So ME is going to be equal to ME going to be equals to P. ME at A, you can just say ME at A is going to be equals to PE. Okay. Well, ME at A is going to be equals to PE. Where is my page now? Okay, it's fine. I wanted it to be more nicer. Let's go to this. Let's try ME at P equals to PE. PE at A plus KE at A. So this is how you can write it. This is mechanical energy. So now, because we already calculated the mechanical energy at A, we found that the potential energy at A, it was 98 joules, and plus the kinetic energy at A, I think it was 9 joules. Yes, 9 joules. So the answer here is going to give you guys 98 plus 9 is going to be 100. So 100 plus 100 plus 100 plus what is it? 100 plus 100 plus what? 100 plus 9 7. It's 107. Yes, it's gonna be 107. 107 joules. If you can use your calculator to add them. So this is mechanical energy A. So now you can be asking me, what is the conservation energy? What do we mean when we say conversational energy? So that when we talk about the conversational mechanical energy, we mean that mechanical energy, I'm gonna go to this diagram here. Mechanical energy at point A, let's assume this is point B here. Mechanical energy at point A is going to be equals to mechanical energy at point B, and it's still going to be equals to each in every point here. Mechanical energy, they are going to be the same. It's just that when you check here, if you are moving down, the potential energy decreases, but the kinetic energy is going to increase. So every time, each and every point, mechanical energy and potential energy, they will balance in such a way that they will make the mechanical energy to be equal. So in each point, mechanical energy is equal to each other. Mechanical energy is equal in each and every point. So that give us make us go to conversational conservation, not conversational, conservation of mechanical energy. So the conservational of mechanical energy state that the ME, I will say ME at point A is going to be equals to ME at point A. Okay, let me just write that you can see it properly. So conservational energy, conservation of mechanical energy. This is this here I'm defining the conservational mechanical energy. So the conservational mechanical energy, ME at A, at point A, we'll say ME at point A is going to be equal to ME at point is going to be equals to ME at point B, and also it can be also equal to ME is equal to ME at point C if you have a point C. So each and every point in that diagram, the mechanical energy, they are going to be the same. So what does it mean? It means that if we have, it means that if the mechanical energy, remember, mechanical energy at point A is the same as PE at A is going to be equals plus KE at A is going to be equals to PE at point B plus KE at point B. So we can write this as, we can rewrite this as this way. We can say in terms of the formula, we know that ME at point A is mgh at point A plus 1 over 2 mv squared at A is going to be equals to mgh at B plus 1 over 2 mv squared at B. So now this is a formula. So what will happen in this equation is that they are going to give you, might give you a mass, then sometimes you might be asked to calculate the velocity. You might be asked to calculate a velocity, and then you will be asked first to calculate maybe the potential energy of point A. You are asked to calculate the kinetic energy at point B, and then after that you will be asked to calculate, maybe they even calculate you at the potential energy at point B, and they ask you to calculate the velocity at point B. So let me just show you what happens. So in this calculation that we are busy with here, we managed to calculate the kinetic energy at point A. So we found that the kinetic energy at point A is 107 joule. So what happens here is that now, let's say the question says, it can say to you, calculate potential energy at B. Calculate the potential energy at B. So the potential energy at B, we are going to state that. Let's just continue with our question. So the potential energy at B is going to be PE at B is going to be equals to mgh. My hand today is not really coordinating properly, so bear with me guys today with my hand. mgh at B, which is going to be equals to mgh at B. I think we already calculated it, because I think we say is 2 multiplied by 9.8 multiplied by 2, and this is going to be equals to 39. I think it's 39.2 joules. Yeah, I think we calculated this before. So now the question says calculate what? Calculate the velocity at B. So to calculate the velocity at B, we know that we can use the conservational mechanical energy formula, which is this one that I just wrote here. So in order for you to use it, which means we already calculated the P, mechanical energy at A. So because we already calculated the mechanical energy at A, so what I'm gonna do, I'm going to say, okay, because the mechanical energy at A, it was 107, I'll say 107 is going to be equals to the PE at B. We found that is 39.2. Then plus, we're gonna say 1 over 2 at B. And we know the mass is 2, but we don't know the velocity at B, v squared. So this is going to cancel each other. Then we're gonna take 39.2 the other side. Then you will see that it's going to be 107 minus 39.2, which is going to be equal to v squared, because we are subtracting, we're taking it that side. So if you use your calculator, let me use my calculator now. If you use your calculator, you will say 107 minus 39.2. Yeah, I think it's 39.2. You can verify. So we got the answer 67.8. So the answer here, it implies that our v squared is equals to 67.8 is. So when you can apply a square root, right? Apply a square root, then you can use your calculator. Then this implies that v is equals to square root of 67.8. So this is a meter. Don't forget the unit is meter per second squared. You can write it up there, or you can meter. You can also write it this way, or you can write it this way. You can say m dot s to the power negative 1. So guys, I'm going to continue with this lesson of mechanical energy. I'm gonna send you a video showing you an example and the questions they normally ask, and I will be answering them. So I'm going to be the next second video, let's say the third video, I'm going to be teaching you guys about the equation of motions. So thank you guys, and if you are loving this video, share with your friends and comment. Let me know in the comment section which chapter do you want me to teach you, and also in the comment section let me know which chapter do you want me, and then maybe you can also ask me to do some questions. You can let me know which question paper should I touch with you guys, and all the best.